Hello everyone, welcome to this online class session. I hope everybody are safe and fine and healthy in your home. So today we are going to start the first class in science, which is from the physics chapter. Okay, so before I proceed to the chapter, I'd like to give a warm-up session for you all. So in this warm-up session, I would like to recall you a class 7 concept which you have studied in your previous class. I don't think so you guys might remember because there is a long holiday which you have got right now. But then again I'll try to recall in such a way that you can able to remember what you have learned in the class 7, because this chapter is going to connect with the topic which you have already learned in your previous class. Okay. So right now I'm going to display a picture on your screen. You can see here. What do you observe on this screen? There is a biker who is riding his bike. So by saying this, what comes to your mind? So is he riding very fast or very slow? So by seeing this, you can judge and you can imagine and you can say that this biker is riding his bike very fast, right? Now there is another image for you. You can see this is nothing but a bullock cart. Now, what will be the speed of bullock cart when we compare it to the person who is riding the bike? So you can easily say that the person who is riding a bullock cart is traveling at a very slow pace, right? He cannot travel at a fast pace. So this concept you have already learned in class 7 in the chapter called motion. So motion is nothing but an object which travels from one place to another place in a specific interval of time. Okay, so if I want to travel from Vanembadi to Ambur, if I travel in a bullock cart, it will take me nearly from some 2 to 3 hours, right? Depending upon the speed of the bullock cart, the speed with which the bullock cart is riding. The same way, if I travel from Vanembadi to Ambur in a bike, I can able to reach to Ambur in just hardly some 20 to 30 minutes, right? Because when we compare the speed of a bullock cart with a bike, the speed of bike will be much faster when compared to that of bullock cart. Okay. Okay. I'd like to give another example. So you can see here, what is this actually in the first picture? In the first picture, a goalkeeper is trying to save a goal, right? So you love to see football, right? So whenever a footballer hits the football to the goal, what the goalkeeper will try to do? He will try to save the ball so that that team should not get a score. So every opponent team, whenever a footballer kicks the ball towards the goal, what the goalkeeper will do? He will try to save the ball. Now what is happening here when he tries to save the ball? So initially when the footballer kicks the ball, the speed will be much faster. The motion with which the ball was traveling will be much faster. But when a goalkeeper tries to save the ball, the speed of the ball is getting reduced. And that's the reason why you can able to stop the ball easily. That's what you might have learned in class 7. Similarly, in another instance, in another picture, what do you see here? A hockey player is flicking a ball. So initially when the hockey player is just passing on the ball, it will be in somewhat in slow motion. But when he tries to flick the ball, when he tries to hit the ball, then what will happen? The motion of the ball, the speed of the ball increases, right? So it is quite opposite to the one which you have seen in the football. So in the football, the goalkeeper is trying to save the ball, whereas in this another picture, the hockey player is trying to flick the ball. So while flicking, what will happen? The motion increases. And in third picture, what do you see? It is about a game of cricket. So in a cricket, what he is doing, the fielder is trying to stop the ball again. So it is similar to what the goalkeeper is trying to do in a football. Okay, the way the goalkeeper is trying to save the ball, stop the ball, the same way what he is also doing in cricket game. So whenever a batsman hits towards the boundary, to stop the boundary, what the fielder will do? He will try to stop the ball. He will try to save the ball. Now, what is common among all these three? How this force, how this action is being done? How can we change the momentum or the speed of the any object? It may be cricket ball, or it may be hockey, or it may be football, or it may be any other bike, car, whatever you take. So how this change in motion happens? So the change in motion happens due to the force which is being applied on a particular object. So now you might have got a hint. So today's topic and our chapter's name is about force and pressure. So our chapter name is about force and pressure. Okay, so shall we move in straight to the chapter? So today's learning objective is, in this module we are going to learn about force, which is mainly about a push or a pull. And also the students will be able to learn the different forces applied due to an interaction. So it can be any interaction, be it hitting or flicking or stopping, whatever you are doing an action. So during that action, what type of different type of forces which is being applied, that we are going to learn in this class. Okay, so children, just listen carefully and observe the different phenomena which we are going to learn in today's class. Okay, so first thing, again I would like to show you one picture. So what do you see in this picture? So what this boy is doing, what this small child is doing, is trying to pick the ball, right? So you can see here, what is his action? So this action represents that he is trying to pick the ball which is lying on the floor. So a ball was already lying on the floor. So what this baby is doing, he is going and just trying to pick the ball. Okay, very good. Another picture I will show you. What do you see in this picture? In the animation itself, you can able to determine. So the girl is trying to open the door, right? So she is opening the door and welcoming you. Now, what action you can represent by seeing this picture? I hope so you can able to easily identify. It is either the action of push or pull. Can you determine? Yes, it is the action of pulling. So she is pulling the door towards her. You might have seen whenever you visit any shopping mall or a hospital or anywhere, even in schools, in the door there will be two stickers which will be pasted. One is about push and another is about pull. So when will you push the door? If you are moving the door away from you, that is called pushing. But if you are trying to pull the door towards your side, then it is called pulling. So what effect it is actually, she is just opening the door, which means she is trying to pull the door towards herself. Okay, fine. Okay, another instance I'll tell you. So what this man is doing, he is a bodybuilder, so he is trying to lift the weight. Okay, so what is this actually, what this action represents? Just now I gave one hint. This is nothing but lifting. This is the lifting process, right? So even when you become a little more younger, what you will do, you will go to gym and all, and you will try to do bodybuilding. So at this time, what you have to do, you have to apply this force, that you have to lift heavy objects. Okay, fine. Another picture I'll tell you. Oh, you love to play sports, right? So what is happening here? The footballer, so this kid is trying to kick the ball. This kid is trying to kick the ball. So what is this action represents? This action represents kicking. So you can see I have given a lot of hints now. So how many types of forces we saw? One is picking, another one is opening the door, and the third one is lifting, and the fourth one is kicking. So these are all the different actions which you might have noticed. Now, based on these actions, I'd like to give one small activity for you. Okay, just observe this table. It is also given in your book. Okay, so below table gives some example of familiar situations involving motion of objects. So whatever you have seen now is also an example for motion of objects. Okay, that is picking a ball, uh, lifting a weight. Everything is also an example, and it also involves the motion of objects. Okay, now in this tabular column I have given few situations, and for one situation it's already been solved. Okay, so you need to exactly determine what type of action is being applied on different situations, and you should also need to denote that whether this action contains push or pull force, which type of force is being applied in that action, that you need to represent. Okay, so here moving a book placed on a table. So moving a book means you're trying to push the book, right? So which type of action is applied? Pushing. So either you can push the book, or even you can pull the book. You can pull the book towards yourself, or you can push the book away from you, and you can also lift the book in your hand. Okay, so these three actions you can do if you want to move a book from a table. So one thing is you can push the book, you can move away from you, or you can bring it towards you, or you can pick the book. Okay, any other thing you can do? You cannot do any other thing. So these three actions are standard actions which you can do in this particular situation. So here pushing is also done, pulling is also done. So it can be grouped as, it can either be pushed, yes, and it can also be pulled. Okay, so you have to mention it as yes, yes. Second one, opening or shutting a door. Just now I gave one example during the warm-up session. So the girl was trying to open the door. So as I said, you can either push the door, or you can also pull the door. Pushing means moving away from you. Pulling means moving towards you. Any other thing you can do, you can also shut the door, right? You can close the door. That is called shutting. So these three actions you can do. So you have to write here pushing, pulling, and also shutting. So can we group these into push and pull? Yes, you can also group this situation as push as well, and also you can pull the door. Okay. The third one, drawing a bucket of water from a well. Drawing a bucket of water means, if you want to take the water from the well, what you are trying to do, you are trying to pull the bucket. You're trying to pull the bucket. So which type of action is being applied? Pulling is applied. The second one, you can also lift the bucket. Okay, so after pulling, if you want to take the bucket, you can also lift it. So only here pulling option is being applied. Okay, so while drawing the bucket of water from the well, either you are applying pulling or you are applying lifting. You cannot push the bucket. Okay, if you try to push the bucket again, it will fall on the bin. Okay, so here no pushing action or no flying action, no kicking, anything. Okay, so here what type of action is being applied? Pull alone is applied. There is no push here, so you should write no in place of push, and in place of pull you should write it as yes. So like this, the fourth situation, a football player is taking a penalty kick. So penalty kick means what? A footballer will definitely try to hit the goal. So what he will do, what action is being applied? Hitting is applied, and also the footballer will try to push the football away from him, okay, or flick the football away from him. So hitting and flicking is applied, so that exactly is the action of pushing the ball towards himself. Okay, so here there is no pull. So what you have to do? You have to put push. Okay, then a cricket ball hit by a batsman. Again, if you want to hit the ball, so a batsman, what he will try to do? He will try to hit it. One thing is he will hit, so hitting is being applied, and also he will try to flick it. So hitting and flicking is being applied over here. So hitting and flicking is also an action, comes under pushing the ball away from you. You're not trying to pull the ball, trying to push the ball away from you. So now you might have got one idea. So among all these situations, what type of force is being applied? Yes, the force, the major force which are being applied in all these situations is either push or pull. Right? Now, what is a force? A force is nothing but in science, the push or pull of an object is called force. Now you might have understood the concept, right? So what is a force? Push or pull on an object. So if you take any object, if you're trying to push the object, that is also force. And if you're trying to pull an object, that is also force. So it's a very simple definition for force. So we can say that the motion imparted to objects was due to the action of force. So all these actions which you have seen, right? Flicking the ball, hitting the ball, pushing the door or pulling the door, whatever, lifting the book, everything. So what type of, how this motion has happened among object? That is because the action of force, whatever the action of force which you are giving, either pushing or pulling or lifting, whatever you are doing. So major action which is being applied is because of the force. Because force is made up of what? Both push and pull of an object. Okay. Now I hope you guys would have understood. Now there is one more question for you. When does force comes into a play? Okay, when can we apply this force? Okay, so shall we see the answer to it? Yes. So let's find out. So the first thing is force is due to an interaction. So when are we going to apply the force? If I am sitting normally, I am doing yoga or something. So I am not applying, I am not doing anything, I am just sitting idle. A statue, if you see, a statue is always sits idle. He cannot move from one place to another place. So we cannot apply or we cannot impart any force on that object, right? But if a human body moves from one place to another, okay, if you are doing cycling, if you are riding a bike, whatever you are doing, any action, so that action happens because of some interaction with different object, right? So a force come into action when you do some interaction. Okay, please keep that in mind. So when you are going to apply the force, so a force is directly applied due to some interaction with objects. Okay, I'll give an instance, one example. So what do you see in this picture? So in this picture, a man is sitting in a car, and this car is not moving actually. This car is just standing idle, and that man is also sitting inside the car. And another man is standing behind the car. Is he doing any action? No, right? He is not touching the car. He is not doing anything. Okay. In another instance, so we can easily say that this man is just standing behind car. Okay. In another picture, now there is a change here. So what that man is doing is trying to do something, apply some force to the car. So what is this actually? So a car is being pushed by a man. So in the first picture, as you have seen, now in this picture, will the car move? If it doesn't push, imagine the car has been, the fuel is empty or something. So the car is just standing. And if this man just tells that person who is standing behind the car not to do anything, do you think the car will move? No, right? So some sort of force has to be applied so that the car can move from one place to another place. So that is the reason why. So what that another person is doing now, he is trying to push the car. So here what is actually happening? He is applying force to the object. So what comes into the interaction? The man is interacting with the object, that is the car. So because of the interaction, because of the force which he is applying, the car can move from one place to another place. Okay. Few more examples we can see. So what these two girls are doing, you might, I mean, especially these girls, this is a girly game. I don't think so even boys can play this, but mostly these games, this type of game will be played during your PT period and all, will be, I mean, among girls. So what is this actually? They both are trying to rotate themselves. Okay, they both are trying to push. So can you able to identify who is pushing whom? You cannot able to identify, right? Because they both are trying to put equal force among themselves when they are trying to rotate, when they are trying to run. So they are trying to apply equal amount of force. There is some sort of equilibrium which is being applied over here. So you cannot determine who is trying to push whom. Okay, but in another instance, in this game, what is happening? Who is pulling whom? Here also the same case. They both are pulling, right? But at equal forces. But at equal forces. So you cannot determine which girl is pulling whom. So in both the cases, yeah, there is a force being applied. These two girls are also pushing each other. And in the other picture also, these two girls are also pulling each other. But we cannot determine who is pushing whom and who is pulling whom, because an equal or balanced forces are being applied over here. Okay, so you need to understand this. Okay, I'll give another instance similar to this example. Okay, so what do you see in this? Okay, so this farmer or any man is trying to pull a cow. Now, can you able to determine who is pulling whom? Who is trying to pull whom? So this man is trying to pull the bull. So who is applying more force? Who is trying to apply more force? So a man is trying to apply more of his strength so that he can able to pull the cow towards himself. Because the objects, these both objects weight is not equal. In the previous case, among these girls, they both are having same weight and they are creating a balanced force among themselves. They are trying to either apply equal push or equal pull. So you cannot determine easily who is pulling whom and who is pushing whom, right? But in this case, since the weight of the cow is more when compared to the weight of the man, so the man has to apply more force so that he can pull the cow towards himself. Is that clear? Is that clear, children? I hope you guys would have understood the difference between the balanced force and unbalanced force. So here in this case, these two forces are not balanced. So here one person is applying more force than the other. Okay, clear? Okay. So from these examples, we can infer that at least how many objects should be there if you want to apply force? Two objects must be there to interact for a force to come into play. So an interaction of one object with another object only results in a force between two objects. So until and otherwise two different objects are not being not interacting, you cannot generate or you cannot apply any force. Is that clear? Okay. Now, with this, I'd like to conclude today's session. So before conclusion, I'd like to give a quick recap on what we have learned today. Okay. So what are all the things we have learned? In science, a push or pull of an object is called force. And how many objects must be there? At least two objects must be there to interact for a force to come into play. And an interaction of one object with another object results in a force between two objects. So always remember, for a force to apply, there has to be interaction between two different objects. Now let's do a quick assessment for you. So just maintain a separate notebook for this. So if you have a notebook, just pick your notebook and try to answer to these questions on your own. Okay, or you can even refer the video, the previous slides, and you can answer from this, but don't try to answer as it is from the book. Okay, so at the most try to answer to these questions on your own, which is related to what we have seen in today's class. So the first question is, what is a force? And the second question is, identify the given picture and infer whether it is a push or pull. So here are two pictures for you. So you just have to identify in the first picture which type of force is being applied. Is it a push or a pull? And also in the second picture, you should identify and say whether the force which is being applied is of push or pull. Okay. Then you have a small home fun for you. So what you have to just do is, it says it's a kind of a situation based question you need to answer on your own. Okay, so try to find the answer for the following. So the first question is, give two examples each of situations in which you push or pull to change the state of motion of objects. So in this class I have given you so many examples, right, where you can able to apply the force for the action of push or pull. Likewise, any other example which comes to your mind, okay, in daily life situations that you can give. And second one is, in the class 6, that is in 6th standard, you might have learned that a magnet attracts a piece of iron towards it. There was a lesson called magnetism, right? So in magnetism you would have learned that whenever you keep an iron nail or something, so a magnet will easily go and attract towards it. So is that attraction is also a pull or a push? So you need to identify. So what about repulsion between similar poles of two magnets? So similar poles mean north pole cannot attract, south pole cannot attract, right? So they will repel from each other. So is that also a pull or a push? Does that type of force also can be considered as a push or pull? That you need to think and try to answer it on your own. Okay, so that's all for today, children. So we will meet in our another class. So till then, stay safe at home, okay, and try to revise all these concepts. Okay, so till then, take care, children. Bye bye.